So today we're going to be putting together what we know about graphing lines and what we did yesterday with our intro to systems of equations. So first, just a reminder, a system of equations is a way to compare graphs and equations of lines. We're focusing on the lines.
Could I just do this?
So we kind of talked about yesterday how to, or what a solution looks like. So this example here is asking if this point 2, 3, so 2 is our x value, 3 is our y. Darn now.
What?
It's asking if this point 2, 3 is a solution to the following system. So to know if it's a solution, that means if we plug in this point into both equations, it should give us a true statement. So if we plug in 2 and 3, we should get 11, and if we plug in 2 and 3, we should get negative 13. So we just have to try it and see if it works for both of them. Remember, it has to work for both. If it only works for one and not the other, then it's not a solution. Question?
Where's that warm-up that you said I could do?
Folder from yesterday?
Which one? Which folder?
The green folder that says Thursday. So we plug in 2 for x and 3 for y. Oops. That'll give us 2 plus 9, which is 11. So that's true. So our first one is good, but we still have to check our second one because it has to work for both. So we plug in 2 for x and 3 for y. Gives us 2 minus 15, which is negative 13. So since it's true for both, so true for both. So it is a solution. If it only worked for one and not the other, then it would not be a solution. It has to work for both. Okay, so how to solve a system by graphing. The first thing you're going to do is graph your lines. And then you're going to look for the point where they intersect.
Scroll up, please.
You know, it would be a video on mathhogan.weebly.com. All right, so if you remember from yesterday, we talked about how the solution to a system of equations will always be a point. So you need an x value and a y value. So I'm just going to write my empty point thing up there so I remember that I need to have both an x and a y for my answer. So we now need to graph these lines. On our first equation here, we have x plus 5 equals 5. There is no y in that equation. So if we get x by itself, we subtract 5 from both sides. We'll have x equals 0. Remember, when it's just x equals a number, that means we have a vertical line. And the x value of 0 is the y-axis. So this is our first line on the y-axis. Okay, so that's our first line. For our second one, we can get y by itself. This is similar to one of the problems that was on the warm-up today. So we could, because if we get y by itself, then it'll be in slope-intercept form, which you guys love so much. So we can subtract 3x from both sides. Remember, the 3 and the x, those are together. They're one term. You have to move them together. So we're left with negative y equals negative 3x plus 3. But then y is still negative, so in order to get y completely by itself, we have to divide everything by negative 1. So we have y equals positive 3x minus 3. And so to graph it, our b term or our y-intercept is whatever the number is that's not attached to the x, or the constant. See, that's a constant. So the y-intercept 0, -3. And then our slope is the number in front of x. It's a +3, or it's like 3/1. So we're going to go up 3 and right 1. So up 3, right 1. Up 3, right 1. We have our line.
That's a good line you just did.
Thank you. Took a whole class in college how to draw straight lines.
Did you really?
No, but I like that you believe me.
I know.
Okay, so now we have our two lines graphed. So where do these two lines intersect? Where do they cross? Yeah, this point right here, 0, -3. Oops, -3.
Not by one of those square crib. One of those little,
What?
oh, not bad. Okay,
Okay, so our solution is that intersection point, 0, -3. That is our answer. Again, it has an x value and a y value. It is a point. So this is our solution. Okay. Can you guys try example 3? So you're going to graph these two lines. They're both already have y by itself, so you can just find your y-intercept, use your slope to get some extra points, and find the point where these two lines intersect. So go ahead and try example 3. Okay, so here's what it should have looked like when you graphed your two lines. Here's our first one, y equals x plus 1. Gentlemen. You have a y-intercept of 1 and a slope of 1. And then our second one has a y-intercept of, oops, sorry, that's a -1. And a slope of 3. That's a highlighter, not an eraser. Oh my goodness. There we go. So what is the point where these two lines intersect? 1, 2, right here. So our solution is that point, 1, 2. Okay, so these ones worked out where our intersection point was a nice point and it was easy to see on our little 10 by 10 coordinate plane there. However, sometimes it won't be as obvious, and so we can use our calculators to help us. So if you guys will get your graphing calculators out, I'm going to show you how you can use your calculators to figure out these solutions as well. So first, when you're doing this in your calculator, you have to have both of your equations solved for y, because you can only type in equations into your calculator that are y equals. So you're going to solve both equations for y. So it'll be in slope-intercept form. So in your calculator, you're going to hit the y equals button, which is this button on the top left here, right underneath the window. Some of yours I know get worn off, so this is y equals right here. So hit y equals, and then you see a list come up that has like y1, y2, y3, y4, all that fun stuff. So you're going to type your first equation into y1, second equation into y2. So for an example, let's use this one that we just did before, example 3. So remember when you are typing in an equation, so our first one is x plus 1. No. The button you use for x is this button right under mode, where it says x, t, theta, n. That button is what you use for x. So it'd be x plus 1 and y1. Did you hit y equals? So you're seeing like the y1, y2, y3, all that fun stuff? Yes. So in your first one, we're gonna just use example 3 for this to show how to do it in the calculator. So you're gonna type x plus 1. The key you use for x is right under mode. This button right here. So you get x. And then in your second one, it'll be 3x minus 1. So 3x minus 1. You can hit graph. So if you guys hit graph, some of you might still have it set up for the scatter plot stuff we were doing. Yeah. Yeah, so if you don't want to see those dots anymore, hit y equals again. And then if you look at the top, you should see that plot 1 is highlighted, right? Yeah. If you hit the up arrow so that the blinking cursor is on plot 1 and hit enter, it will unhighlight it. And then if you go back to your graph, those dots should be gone. Okay. If your window also ever gets weird where you can't see stuff or it's like very zoomed in or very zoomed out, if you hit the zoom button right in the middle here and then go to option 6 that says Z standard, that'll bring it back to your 10 by 10, one that we're used to seeing. Okay, so now once we've graphed it, again, it can be a little difficult to see exact points in the graph. So you can look at the table. If you remember how to get to the table, you hit the second button and then graph. So everybody hit second graph. And then in the table, to find our solution, you are looking for where both equations have the same y value. So if you see it says x and then it says y1, y2 in your table, so you're looking for where y1 and y2 have the same y value. Do you guys see that anywhere in the table? Yeah, the y value of 2. And what's the x value? 1. So again, that's our solution that we got, 1, 2. Now, sometimes our solution might not be a nice whole number, like that one, or like our table likes to just go by like -1, 0, 1, 2, 3, goes up by 1s. So underneath here, I give you some hints on how you can adjust the table settings so that you can make the increments smaller so you could be able to see smaller increments. So if you hit the second button and then window, which is the button right next to y equals, everybody together, second window, that'll take you to table setup. Guys, because you're talking and you're missing what I'm saying. Okay, so second window. Window's right next to y equals. Yeah. And then if you go down to the second row there, it has a little triangle, TBL. Yeah. That tells you what your table is going up by. So you can change it like to go up by 0.25 if you want. So if you type in 0.25 instead of 1, then if you go back to your table, second graph, now your table is going up by 0.25 instead of 1. So that can be helpful if your solution is not a whole number. Or we can use our graph to approximate. So if you go back to the graph, hit the graph button. And I actually changed my mind. I don't want to use trace because we can find the exact one. And trace is just an approximation. So we're not going to use trace, but if you hit the graph button and then hit second trace, so hit the second button, and then trace is right next to graph. So second trace. Yeah, Austin?
Mine graph button really, I click it and it says error invalid.
Go to y equals and make sure that you don't have some weird stuff typed into any of those, or make sure plot 1 is unhighlighted. So you hit second trace, right? Are we all there? Guys,
Yes,
come on, work with me here. Second trace.
I would. And then we go to
Oh.
5.
No, I accidentally took one of the batteries out.
Second trace, and then, yep, select option 5, which is intersect. Then 5, intersect. You're going to hit enter again, hit enter again, and then you should see at the very bottom of your screen it should say intersection, and it gives you an X and a Y value. It gives you the point. So you're going to hit enter because it wants to know where the first line is. Then it goes to the second line, you hit enter again. For some reason it wants you to guess what the intersection point is. Don't know why, but you're going to hit enter again. And then your intersection point pops up at the bottom of your window.
I did it.
Good. Anybody have any issues seeing that intersection point?
I didn't even get a calculator.
So happy. Okay, also, I have just some information here on how to zoom. So again, Z standard brings you back to the regular 10 by 10 coordinate plane that we're used to seeing. If you ever want to zoom in, you can do this. So just some helpful hints here on how to use the calculator. So just remember all this stuff is in your notes, okay? All right. So if you guys want to just use the intersect and you don't want to worry about changing the table settings, if you guys want to change table back, just hit second graph right now and change that, or sorry, second window, and change that triangle TBL back to 1 if you want, if you don't want your table to look fun with all those decimals.
This is crazy.
Wow. Great numbers.
Wait, we're not done yet.
Yeah, I want to be done.
Okay, so example 4. Now we're going to solve by graphing. So to use our calculator, we have to get y by itself for both of these. So to get y by itself for the first one, we have to subtract 2x first. Again, that 2x is stuck together. So we have 3y equals negative 2x plus 6. And then we divide everything by 3. Every single term gets divided by 3. So we have y equals negative 2 over 3x plus 2. Okay, so that's our first one. So we can graph it by hand or we can do it in the calculator. So 1, 2. Then we go down 2 over 3. Down 2 over 3. Okay, so there's our first one. Then our second equation, to get y by itself, we just have to subtract 2x from both sides. Gentlemen. So our second one has a y-intercept of negative 2 and a slope of negative 2. So down 1, right 1, down 2, sorry, right 2, down 2, right 2.
Miss Hogan,
Mm-hmm.
are you going to the game tonight? What, kid? What's the kid?
Okay. I don't know.
Oh, something weird happened this. Oh, I'm gonna tell you right now.
Okay. All right, so we can kind of see on our graph where it intersects, but I just want to practice using the calculator so you guys get comfortable with that. So in the calculator, are you guys ready? You're gonna hit y equals.
Wait, hold on. I don't know how to graph.
Yep, we're gonna do it in the calculator. So everybody in the calculator, y equals. Clear what you have in y1 and y2. So just, it's blinking over y1, hit clear. It's blinking, then move it down, so it's blinking over y2, hit clear. Okay, in y1, we're gonna type in our first one. So negative, fractions go in parentheses. So negative parentheses, 2 divided by 3, close the parentheses. X, remember your X key's under mode, plus 2. Then go down to y2, then we have negative 2x minus 2.
X plus 2.
Minus 2.
I know, it's just,
Okay.
I was just joshing.
Okay. So again, we can look at our table if we want to see if we can see where our y values are the same. Can you guys find anywhere where both y values are the same in the table?
How do you get to the table? Second graph.
Second graph.
No, I can't.
Okay, if you can't see it, that's okay. So if you hit the graph button, remember we have our magic intersect button. So hit graph. It'll take a minute to graph your lines for you.
Oh, I did mine completely wrong.
Obviously.
Then you hit second. Trace. Go down to option 5.
That's why, 'cause it's supposed to go to the
Hit
left.
enter like 3 times. 1, 2, 3.
-3, 4.
-3, 4.
Everybody.
What?
I should figure out how to flip the equations to get the y equals straight. This is the funny.
I use creatine.
All right, example 5. So solve by graphing. Using the graphing calculator, can you guys take a minute and do this one on your own? So you need to get y by itself, then plug them both into your calculator, and you can use your intersect button or look at your table, but find the solution. So here on when we sketched it, our coordinate plane isn't quite big enough to see the intersection point, so this is where your calculator comes in handy. So this is what you should have had for your 2 equations when you got y by itself. You could have a switch. You could have -2x plus 1 and -4 minus x. That's fine as long as the signs are the same. So you plug those into your calculator, into y1 and y2. Then you graph it. Use your second trace. Go to intersect, and you should get the point. What is it, Dorian? 5, -9. Okay, any questions on how to use the calculator? Again, you just got to remember what buttons to push, really. So keep your notes handy. Oh my God. Dorian loves math, everybody. It's a happy day.
For today.
I'm going to,
Keep this
for the record, Dorian loves math. Can't be changed. He loves it forever. All right, example 5, solve by graphing. So if we can graph these by hand. So our first one has a y-intercept of 1 and a slope of 1. Yeah, we're moving on. Our second one has a y-intercept of 5 and a slope of 1. What do you notice about these 2 lines? They're parallel, so what does that mean? They have the same slope, which means
That
they'll never cross, so there's no solution.
Hey, I got a question.
Yes, Darnell.
Could you show us this whole lesson without having a whole packet? Like without all of this? Could you show us how to do this without all of this?
But would you guys remember it? You
Yes.
hardly remember when I say simple directions up here.
You ready? Do you say
Yeah.
simple directions?
Exactly. This is my
What
point.
simple directions?
So there's no solution because these lines are parallel. They never cross.
No soul.
So if you didn't realize that right away, because sometimes our sketches aren't perfect, so it might look like the way you sketch it that they might eventually intercept. So if you did plug this into your calculator and did the intersect thing, it would say like either an error or no solution. So that can give you a hint that they're never going to cross.
Never gonna cross paths.
All right, let's take a look at this one. So if we get our y by itself, we would subtract x from both sides. What? Sorry. So y equals 5 minus x. Then for our second one, we need to solve for y. So we minus 2x from both sides. Then what do I do to get y by itself? Divide by 2. Everything is divided by 2. Now, what do you notice about these 2 equations? They're the same. So if we were to graph this, 1, 2, 3, 4, 1, 2, 3, 4, 5, the slope of -1. Then I do it again. It's the same line. Darnell, right? Same line? Darnell. Same line. If it's the same line, what does that mean? How many times is this line going to intersect with the other one? Infinitely many. So infinite solutions. Because they are the same line.
I promise you that's not what it is.
So you would see on your calculator, if you were to graph them, that it would just look like one line instead of two. Okay, our last thing here. So we are going to be learning 2 other methods to solve as well. Solving by graphing would be the best or the easiest option if your equations already have y by itself, because you have to have y equals in order to plug it in the calculator. So the less work you have to do, the better. Is this a real question?
Yeah, could you scroll up so I could take a picture real quick?
There's going to be a video. Am I talking about it?
I was.
Dang, can we get the homework?
I'm not gonna watch it.
My mom says I have to start doing my homework because my guys.
It's good advice.
My mom
So in
said
both
I have to work on
equations,
the computer, bro.
already have y by itself. Because then all you have to do is plug it right into the calculator and you can use your intersect button.